everyone, we're going to do another problem with inverse trig functions and using the sum and difference identities. In this case, we're going to do sine of alpha plus beta. So this is your alpha, and we have tan of alpha equals u. And then over here, we have tan of beta equals v. And in order to do cosine, we need to know what cosine of alpha is, cosine of beta, and we also need to know what sine of alpha is and sine of beta, because this is the formula for cosine of alpha plus beta for your sum formulas. Okay, so the first thing we're going to do is take this one and know that our restrictions here are in quadrant 4 and 1. Same with this one because we're dealing with the inverse. And we already should know our restrictions. Okay, now, so the best way to find cosine and sine is using secant. Because remember, secant's 1 over cosine. So basically, if we get secant, we know that that's the square root of, and be sure to watch the previous video because kind of went a little slow on that one. That is going to be tan squared of alpha plus 1. So we know that tan of alpha is u, so that's really going to be u squared plus 1. Therefore, cosine of alpha is just going to be 1 over that. Alright? And then for sine of alpha is going to be 1, sine squared of alpha, you know, is 1 minus cosine squared of alpha. So we're just going to write this in square root both sides. And we get sine of alpha equals square root of 1 minus cosine of alpha squared. So that's just going to be 1 over u squared plus 1, because I did the square root of that. You square root the square. Okay, now I'm going to just get the common denominator, and that's going to give you u squared plus 1 minus 1 over u squared plus 1. All I did was cross here, and I multiplied these two together to get this part, and I multiplied those two together to get this part. And when you simplify that, you're going to get u squared over u squared plus 1, that's the square root, and further simplifying that would be u over square root of u squared plus 1. I just simplified the numerator there. Okay? Now, what's going to happen is, think about it. The tan of beta is going to be the exact same thing that I just did, so I don't think I need to do it again. But instead of u, what are we going to have? We're going to have v. So basically, what we have is cosine of alpha equals 1 over square root of u squared plus 1. Sine of alpha equals u over square root of u squared plus 1. And then our betas are going to be the exact same thing, basically. Cosine of beta is going to be 1 over square root of v squared plus 1. So why did I write u? Because I'm copying. So v squared plus 1, and cosine of beta will be the same, but it'll be v over square root of v squared plus 1, because it's the same thing. They were both tan. And putting it all together with our formula of cosine of alpha, cosine of beta, minus sine of alpha, sine of beta, I'm just going to substitute. So cosine of alpha is 1 over square root of u squared plus 1, and beta is 1 over square root of v squared plus 1 minus u over square root of u squared plus 1 times v over square root of v squared plus 1. So my common denominator is these two put together, those two put together, because they both have them here. So I'm going to put square root of u squared plus 1 times square root of v squared plus 1. And then I just put the top together. So 1 times 1 is just 1 minus uv. I just multiplied those two and those two. All right, that's all. Thank you. Have a nice day. Bye-bye.